Hello Rosenbergers, good to see you all again. Today I'm going to discuss a physical quantity called displacement. A physical quantity is something that we can measure, for example length, time or mass. For displacement we only need two things. We need a ruler to measure the distance the body has travelled. It could be a car, it could be a boat, it could be a person, and we need a compass, because displacement, you cannot work with displacement unless we know the direction the body has actually travelled in. That will be clearer as we go through the video. The first thing I want to do is illustrate the difference between distance and displacement, and to do that I've got a short video of 4 cars. Let's watch this. Any physical quantity that has a direction associated with it, we classify that as a vector, and we can draw it in our jotters as directed line segments. This, for example, represents a vector. The arrowhead is the direction the vector is pointing in. So for example, this vector here is pointing due north. This vector here is pointing due west. The length of the vector is proportional to the magnitude of the physical quantity that we have just measured. Let's go and illustrate this just now. This is a directed line segment that we call a vector. Now we label vectors. This is called the toe of the vector, and the top, the arrowhead, is called the head of the vector. This vector is clearly pointing due north. Now the length of the vector is proportional to the magnitude of the physical quantity we have just measured. So for example, if this vector here represents a displacement of 100 kilometers due north, a vector half the size will represent a displacement 50 kilometers due north. This is how we scale our vectors. Vectors can be added. Before we add vectors, we always must draw them head to toe like this. So I have to make sure the head of this vector is next to the toe of this vector here. This is a one-dimensional motion. This is the best way to draw it. So basically, what is this vector plus that vector? What is the answer to that? Well, the answer to that is something called the resultant vector. And to find that, we draw a vector from here, tail of the first vector to the head of the last vector, and that's called a resultant vector there. If this is 60 and that's 30, this is also going to be 30. In other words, if this is 60 north, that is 30 south, this will be 30 due north. And that's how you add vectors. Notice, whenever you see two heads together, one of them has to be a resultant vector or the diagram is wrong. Well, Rosenbergers, that was a very short video on the displacement vector in one dimension. My next video will be the displacement vector in 2 dimensions, and you'll start to see the real value of the displacement vector. Thank you very much. I'll see you next time.